Here we go. So the difference in this and what we've already done is we've factored and solved quadratics. I shouldn't have told you factored. I should let you do that. But it's okay. We've solved quadratics. Now we're going to solve polynomials. Okay. And the only difference in a quadratic and a quadratic is a polynomial, but every polynomial is not a quadratic. Why? Exactly. Quadratic means the degree is 2. It's an x squared polynomial. But polynomials can have any degree. So we're going to talk about really higher degrees, bigger polynomials. So I need to show you two special patterns. And special patterns, we learned some with quadratics. Remember we had difference of two squares? What was another pattern we learned?
Perfect square trinomials.
Perfect square trinomials. And of course, we haven't grouped with polynomials, but we will group today with polynomials. But y'all already know how to group. So the first pattern I want to show you is actually, I'm calling it 2, but it's really just 1. It has the same pattern here. Sum difference of 2 cubes. And it's hardest for students to see this because when we have a difference of 2 squares, it factors so differently than the 2 cubes, and this comes out to be so long, but you just have to kind of work with it. All right, if I have 2 numbers that are both perfect cubes, remember when you have perfect squares, it only works when it's difference of 2 squares, right? Notice this works when it's sum or difference. All right, so here's how you factor it. Remember, factoring is breaking it down into things that are being multiplied together until you can't break it down any further, right? All right, so I do a little parenthesis and a big parenthesis. No. All right, so I'm going to do my signs first. The signs are always the same. You do same sign, change the sign, plus. So it's always same, change, plus. Okay? So if you start with a sum of 2 cubes, it's plus, minus, plus. If you start with a difference of 2 cubes, what would it be? Minus, plus, plus. All right, so a cube is something that you multiply by itself 3 times. And if this looks confusing right now, just hang tight because when we do a few examples, it'll start to click. So you take whatever it is that multiplies 3 times to give you this value. So that would be A, and this would be B. Once you have your first little set of parentheses, that's what you use to write the rest. Okay, so my trinomial that follows, I'm going to take the first one and square it. I'm going to take the last one and square it in the last place. The middle puts them together. It looks very, very, very similar to a perfect square trinomial. The only difference is that middle term's not doubled. Okay, so it's the product of the ends but not doubled. So same thing here. Okay? Let me show you an example, because this is a very broad, general definition here. Remember, when we're factoring, we're looking for things like a GCF to take out first before we start. Okay? And all of those factoring rules that we have already learned. Do y'all have this already?
1 second.
What if it is multiple? Like, what if a number you put where B is like 2AC?
They have to be perfect cubes. As long as they're perfect cubes, it'll work. So if it was 8a cubed b cubed, you could do it because it would be 2ab. I'll show you. That was really complicated. Let me show you this one. 8 is a perfect cube.
Because 2 is a perfect cube.
Let me start with one, and I'll do one. Let me do an easy one to start with. Perfect cubes, yay or nay? Yes. What times itself 3 times to give you 8x cubed? 2x. What multiplies by itself 3 times to give you 125? 5, okay? If you're not familiar with your cubes, you might want to write a list of cubes off to the side of your paper. 2 to the third, 3 to the third, 4 to the third,
What is the cube of
5. 6 to the third. I think 7's 343. Is that right? Somebody with a calculator? Pretty sure. I could be wrong though. It's happened before.
Wait, what was the question?
7 to the third power. Is that right? Okay.
I'm gonna have to.
So you'll have to be able to recognize them. I mean, you'll have your calculator if you need it. All right, so the question is, how does it factor? So let's set up our parentheses, little and then big. And same, change plus. Now, I did fail to mention to start with, we look for a GCF. Does this have a GCF? No.
Yeah.
That's exactly right. 2x and 5 is what I'm going to start with. Close, but you got to square the whole thing. So it's 4x squared, yeah. And then what about the last one?
25.
Uh-huh. Why is it what? Well, it started x cubed. And what about this one?
100x squared.
10?
10x.
I'm so confused.
What are you multiplying together? Look, first one in the first spot, last one in the last spot. The middle is these two.
Oh, I thought it was the first.
Okay, you always use that very first little set of parentheses to write it.
Wait, how do you get one squared again?
Squaring this squared gives you this one, and this squared gives you that one.
So, when you're done, you multiply them? Or?
No, you're getting it in factored form, so you want to leave it like that.
You're like working backwards. If you like factor, then you get 8x.
Right,
cubed plus 1. And if you multiply this out, you get 8x cubed.
right, yep. So directions just say to factor if you can. And factor completely. And what factor completely means is that after you have factored, you analyze the factored pieces to see if you can factor any of them any further. That's exactly what I want you to do first, Marshall. You're exactly right. What can you take out of everything? What else?
4. Or 6
An 8.
You can't take a 4 out of 54.
6.
2x. Brush up on your GCF skills there, guys. What's left in the first one? 8x cubed plus 27. So now look at what's in parentheses. Now they're both square cubes, right?
And then once you factor it, you just put the 2x in the
Yep, it stays. Little big? Yep. What goes in the first spot? 2x. Yep. Is this confusing to anybody? We're really just plugging into a formula is what we're doing.
So are we, like.
Or
the
an equation.
Opposite of cubing? Like, okay, if you go 8x to the third, how are you getting the 2x?
What times itself 3 times gives you 8x cubed? What times what gives you 8x cubed? So it'd be 2x. Yes. This will be 6xy. What goes in the first term?
4x squared.
Uh-huh.
27y.
Yep. 9. Yep. Always, you're always going from this very first set of parentheses here.
Oh, so once you do that, you're going to square root that to get 7.
Correct. Well, square, to get what?
You're gonna be, okay, you have your first one on the
Uh-huh.
left, and you're going to, not square root, you're going to square that.
Square it. Uno mas?
Does it have to be
Uno
addition?
mas.
Do the hard one.
Addition or subtraction.
Wait, go back.
If it's subtraction, would that just change the?
It just changes the signs. It's the same change plus. So instead of plus minus plus, it would be minus plus plus.
Okay, are we gonna get any ones where like they're not perfect cubes and there's no way to factor them out to make perfect cubes?
Yes.
Are you gonna
You just put.
Cannot be factored.
Can you give us a hard one?
Like, for example, the directions just say factor each polynomial if it cannot be factored. Say so. Why?
Because they're gonna make it hard.
If this 5 were 125 or 64, it could. But because 5 is not a perfect cube, and there's not a GCF, that can't be factored any further. You check your list of cubes that you have. We will get to where we're doing cube roots and stuff where you can check them, but for right now, just be familiar with that list of perfect cubes. Y'all asked.
Wait, hold on, can you give us a second?
Yeah, give you a second. Try it. All right, let's go. What's your GCF? What'd you take out?
5y.
What were you left with when you did that?
Y cubed minus 64 z cubed.
I spy a difference of 2 cubes.
And then it is y minus
Sorry. Same change plus.
y minus 4z.
This computer's going full. 4z. What goes here?
Y squared plus 4yz, or zy.
Doesn't matter.
Plus 16z squared.
Oh, y'all got this. What is going on?
Just to go, he's back.
Oh my goodness.
They're back with a vengeance.
All right, let's group. You've already grouped, really, because that's how I taught you to factor initially. So this is going to be to your benefit that you really know how to do this already. Oh, okay. No, let's stop.
I have one more page. You forgot the one getting one out. Are you serious? Yes. I have one.
What did we get at 11:15 or 11:05?
Every day.
11:05.
What is wrong with me that I cannot remember that? Okay, factor by grouping. This is fixing to get on my nerves. Okay, factor by grouping. So factor by grouping remember when we're grouping, whenever we have regular quadratics, and we rewrite that middle term into 2 pieces so that we have 4 pieces?
Yeah.
Yes, okay. So factor by grouping starts out with 4 pieces, and it's usually, well, I'm not even going to say that. Starts out with 4 pieces, so if you see a 4-piecer, not chicken though. Can't factor chicken. I don't know why.
We're getting a problem.
Okay, I'm going to change this example because the first example in your book I was going to use is like terribly hard. It doesn't just group the way it sits. X cubed plus 5x squared minus 2x minus 10. So what really you're doing is you're looking for some place that you can take GCFs out of certain terms. Okay, so you're not going to take it out of everything, but maybe there's 2 terms that sit there you can take it out.
Like,
Yeah.
oh wait, is this just, yeah,
Huh?
is this like the same thing that we did?
It is, but you see that, okay, and I'll show you why it's going to get harder in just a minute, but I just want to do this example this way, and then I'll show you why I'm taking time. The way it's written now, it's really easy to see what GCF you can take out of where, right? The first 2 I can take out what? And what's left?
X plus 5, X.
And the second two I can take out, and it leaves me with,
X plus
right? And now, of course, the common term is x plus 5, and then I would have x squared minus 2. And at this point, I would need to stop and look and say, can any of these pieces be broken down any further? In other words, you know, if that had been a 4 instead of a 2, I could do it again and have a difference of 2 squares. But you're right, no, I can't do this any further.
That's right. If that
If-
4, that 2 would have been a 4.
Right.
Because it would have been 2 squared.
Wait,
If
so
it had been
you
difference,
do
yeah.
a difference of 2 squares for like just one.
Yes, yes, absolutely. And that's part of factoring completely, is that we take the factored pieces and we factor even the pieces down further.
So then what will you do with the other one at the end?
It would still be there. So if you had x plus 5 times x squared minus 4, this would become, x plus 5 can't be broken down any further, but this one could become x minus 2, x plus 2. And then it's factored completely. No, because you're multiplying, not.
This is a weird one. Is 1 considered a perfect
Yes.
square?
It's
So
a
if
perfect
it was-
square, it's a perfect cube, it's a perfect, it's perfect everything.
So if it was 1.
Yes, yep. And that does show up a lot. Let me see how well you understand grouping. Because sometimes we might need to group things, and the way these are laid out for you initially are going to be nice in that they're already split. You can clearly see where the split is happening and where you might need to look for a GCF. Do you see where it's occurring, that I might need to group some things together?
Yeah.
There's 2 squares there, right? You see that? So what's a GCF that I could take out of maybe those first 3 terms?
X squared.
X squared, right? And
Why
if,
can't you just combine them?
well, so you could, but I don't think it's going to group then.
So it'd be like X squared in parentheses X squared plus 7 X minus 4.
And that's why they set it up for you like this. All right. So it leaves me with what?
X squared plus 7 X minus 4.
Wait, is it on here?
Well, I'm going to leave the 10x here, and you could, maybe you put it in there, but the point in grouping is that when you take something out, what's left in parentheses match each other. So if you were to put that 10x squared over there, then you'd have 4 terms in parentheses in the first set and only 2 in parentheses. You see what I'm saying? So I really want it to be split evenly, so you always want to split down the middle when you do it. Here,
But like the great fun fact from the last grade was 2.
yes. So when you take it out,
This one isn't. It was saying, was it? No.
Yeah,
You
divide
could
X
just-
squared.
if you could take out, if 10 was divisible by 4, it would work.
so that doesn't work. So is there any other way we might could arrange it where it would work?
Move 4x cubed.
How would we?
Switch the 4x squared.
Ooh.
And the 10x.
Can we combine any of these things? Can we combine them?
We already figured out that.
Let's see. Yep. No, that wouldn't work if we did it. Let's try this. What happens now?
Oh, that would work.
Does it work now?
Yeah, it worked.
Okay.
Take out 2x.
See the do you see what's going on here in the thought process we're having to go through here to make sure? We know it needs to split down the middle, and I know that they split those 2 terms for me for some reason.
Yeah, it does work.
So now I take x squared out. It leaves me with,
Yay, it worked.
yes.
Well, how do you know how to switch them?
Well, you just have to look at it the same way we did. See, we started out and we tried to take it out the way it was, and it didn't work. Now,
And then you can do it in four different experiences X squared.
that's exactly right, Livy. We switched it because whenever we went to take this out here, these weren't going to match. So we knew we couldn't do it that way to start with. So the only other thing we could think of, because we knew it had to be split at the squareds, was switch those around and see if it would work. Yeah.
How would you know how to square
That's when it gets hard.
Wait, what do you do with the x squared plus 4?
Right now, they're going to be split for you for a little while right now.
Okay.
And then you can put in x squared
While we
minus
get used to
4
it.
into x plus 2 minus 2.
Say that again.
Then you take the, whenever you like put them beside each other, you take the x squared minus 4. You also can.
Yes, so I got x squared plus 7x plus 10, and now I have x squared minus 4. Well, now remember I'm factoring completely, so what I'm doing is I'm looking to see if I can factor any further. And this, does anything multiply to 10 but add to 7?
No, but that's the 10 that x.
Wait! Does anything multiply to 10?
Oh.
Y'all, nope, just nope. There's a leading coefficient of 1, so I can just use a little shortcut. There's a factor.
Wait, what?
Remember the shortcut?
Remember, if the leading coefficient is 1, you don't have to go through the whole process of splitting it up. Now, if you want to, so if you did x squared plus 5x plus 2x plus 10, x plus 5, 2x plus 5, so you get x plus 5, x plus 2. You can do all that if you want to, but if you have a leading coefficient of 1, it's a super duper easy factor because
So but in the like final equation, there's gonna be 2x plus 2. Does that like doesn't matter?
there's going to be what?
There's gonna be 2x plus 2.
Oh, I see what you're saying because this is x minus 2, x plus 2. You can leave it like that, or if you so choose, you can write this. Exactly. Y'all are on it today. It's not for once. All right, some of them are going to get a little hairy. But I'm going to stop there because I don't want to get into too much before the bell rings, which means we made it through half the section, which is okay because it's a little, record this with it.
Hey, can you write that in big bold letters so I can hear it?
Do not get frustrated with it. The grouping especially because you're gonna come across some, and let me just show you. These are not in order. Okay, so you need to put them in order, rearrange them, and see what needs to go where and what we need to do, right? I'm just saying, I don't want you to get overly frustrated with them. Put them in the right order that they go. You want to do it together?
Okay, I just have a really quick question.
Okay.
Instead, if you had something like that where there's an even amount of like
Terms.
yeah, could you just like factor them all by 2, like in groups of 2, or does it have to be in groups of 2?
These are gonna have to be in groups of 3. It's gonna have to be split down the middle. Yeah. Yes. And all I'm doing right now is getting it in standard form, but I'm leaving the terms split apart like that, the squared terms. So really your biggest question on this is going to be which order should they go in? Should it be 12x squared minus 5x squared, or should it be negative 5x squared plus 12x squared? Does that make sense? Which should it be?
Are those the two that will switch? Or can you switch
It's fine the way it is.
Well, you could switch anything. I mean, there's no rule about what you can switch, but essentially you want them in standard form that way. And those are going to be the two that that will benefit you to switch.
12.
Yeah,
Because then you
what
could
is
take off
switch?
6. Because 5 doesn't
How
factor
does it
into
go into
30.
a new?
So you would have to move 12.
So do y'all hear the reasoning there?
And then you take out the negatives too.
So 2x to the 4th minus 3x cubed minus 5x squared plus 12x squared minus 18x minus 30. So you try that one real quick and see what you get.
First one works.
Yeah, it works.
Y'all are correct, it does.
Can you factor the second term more because you're.
The x squared plus 6 isn't going to factor anymore, but how about the quadratic? Does anything
2 and
Yeah. You and
5 makes 3, right?
multiply to negative 10, but add to negative 3? So you're right, negative 5 and positive 2?
Wait, how do you what?
So what,
Oh, okay.
we're going back quadratic factoring. So what multiplies to negative 10, but adds to negative 3?
Negative 5 and 2.
Negative 5 and 2. And so that becomes x, 2x minus 5. 1, 2x minus 5. So this quadratic factors as 2x minus 5, x plus 1. That's still a piece of it too. Now we haven't solved yet, and we will be solving. I've got a couple more little things to show you with factoring of polynomials before we do. Let me give you yours.